Class 12th Physics, Ray Optics. So let's begin with some formulae. Refractive index E by V, lambda in vacuum upon lambda in medium, sin I upon sin R, and 1 upon sin IC. IC is critical angle and all those things. Yeah, next is for curved surface, denser to rarer to denser medium, and there is lens maker formula also, and in the same formula I have used lens equation included, then magnification linear and aerial magnification. All right, so let's first question. A beam of light converges at a point P. Now lens is placed in the path of convergent beam. Here it is at point P, and now in the path of this convergent beam there is a convex lens. It is 12 centimeter away, so this P point will act as a virtual object because there is no particular object, definite object in front of the lens. So we will consider that converging point, that up that that converging point uh, as an object, and you can see u equal to plus 12. Why plus 12? Because distance is measured in the direction of incident light. So next is so simple, we can apply lens equation and we can solve it. The key point here is this object distance, which generally we consider negative, but actual reason is if it is in the direction of incident ray, then it is positive, and if it is opposite to it, then it is negative. So image will be formed somewhere here. You can solve it. And okay, moving on, next question. A biconvex lens is formed with the two thin plano-convex lenses as shown. Okay, so okay, from the first lens, plano-convex lens, which has a refractive index 1.5, the other one is 1.2. So it is a question of combination of lenses. So directly applying combination of lenses, and that is equal to 1 upon V minus 1 upon U. U is minus 40 here. So okay, for first lens, first plano convex lens, eta 1 minus 1 upon r minus 1 upon infinity. And for other, if we take first surface as infinity because it is plane, then other surface will be minus r. So here it is. In fact, for if you see any of this type of question, plano convex, just write 1 upon r, one of the radius, and that's all. Now if we substitute the values, now it's an easy question here, so you can solve it of your own. And whatever be your answer, write down in the comment, so that if there is any problem, then I will let you know. Okay, next question. This one. Three lenses, they are not placed in contact to each other. If they were, then we could apply that combination formula. But here we will go one by one. So for first lens, U is 30 centimeter, F is 10 centimeter. We can apply lens equation. 1 upon f equal to 1 upon v minus 1 upon u. I'm putting subscripts 1 1 1 for case 1, and yeah, of course u is minus 30. That was my fault. Anyway, so now from here we can find v1, and the little bit algebra, I mean arithmetic, and v1 is 15 centimeter. So 15 centimeter. Okay, for second lens, you can see 15 centimeter, it will be somewhere here, exactly there actually. So what is its distance from concave is 10 centimeter. You can see if this is L1, this is L2, this is L3, then distance between L2 and L3 is 10 centimeter. And at L3, that image is formed, and that image is acting object working acting as an object. And as this time, as in question 1, we took object distance positive, so also in this case, because incident light and object distance both are in same direction, that is why it is positive. So uh, oh, that's surprising. U is infinite. V is infinite here. You can see how is it possible. Uh, so it means a parallel beam incident on convex mirror, not exactly in the same way as I have drawn, but it is something like this. So if U is at infinity, we will be at focus. So it will be at 30 centimeter toward right. So next question. A point object is placed at center of glass sphere of radius 6 centimeter, refractive index. Okay, so here is C, and at the same point there is optical center also. Let us suppose ray is coming out from it. Then, okay, this is U, and refraction is taking place from denser to rarer. So remember, in the beginning with the formula which I have given, that was for curved surface, but for rarer to denser refraction. But for rarer to denser, but for denser to rarer, we change eta 1 and eta 2 with each other. Eta 2 refers to denser medium, eta 1 refers to rarer medium. As we mark these uh, refractive indices, so we can put the value. So object distance and radius of curvature, actually object distance, object is at center, so that is why radius and object both are same, and both have to be measured with the negative sign. Okay, now identify a correct variation between respective quantities. So first, refractive index and wavelength. Refractive index, mu is written there, we use eta as a symbol, but doesn't matter. So refractive index, we know the formula for refractive index. It is lambda in there it is, lambda in vacuum upon lambda in medium. So lambda in vacuum upon lambda in medium, but see, lambda in vacuum is a fixed quantity. So lambda in medium is varying with the refractive index. And inverse proportion graph, this is not the inverse proportion graph. So moving on, next graph. So here it is. For convex, yeah, of course this is the shape of the graph, but it should be in second quadrant, because for lens, U is negative. Generally when we do experiment, U is negative and V comes positive, because each time we measure uh, distance for real image. So this is also wrong. Now this is 1 upon V, 1 upon U. This one is correct, and that's true, it is in second quadrant. Keep this thing in your mind. UV graph is a curve, but in second quadrant, and 1 upon V, 1 upon U. That you can find in your lab manuals also. That's all.